last class we did some transformations where we took the parent function and then we maybe reflected the numbers, or we added or subtracted. Today we're just going to add on vertical stretch or shrink and horizontal stretch or shrink. So you look at the picture here and you'll see, well, look at the equation, you'll see that for vertical there's a number multiplied by the function. So this is outside of the parentheses. When you look at the picture, the parent function is in blue and dashed, and then a stretch is going to make it rise up faster, so it's going to be closer to the y-axis. A shrink is going to make it not rise up as fast, so it'll be wider. And to know if it's a stretch or shrink, you can just look at the number. If it is bigger than 1 that you're multiplying the function by, if it's bigger than 1, it's a stretch. If it's in between 0 and 1, it's a shrink. So does that kind of make sense? Like if it's a bigger number, it's going to stretch. It's going to go up faster. So if it's bigger than 1, it's a stretch. If it's between 0 and 1, it's a shrink. What if it's a negative number? That's not included here. What's a negative number do? Yeah, it's a reflection. So a negative number is going to reflect it, and then we might have a stretch or shrink on top of that. Now horizontal is totally opposite of what you think. So when you look at the equation, horizontal has a number multiplied by x, but it is inside parentheses. And everything's opposite of what you think. So when we have a number between 0 and 1, that's the stretch for horizontal. When you have a number that is greater than 1, that's the shrink. So it's kind of opposite of what you think. And if you look at the picture, the parent function is in blue, and then we have a stretch in red that makes it, I lied, it's not a stretch, a shrink. It's let me do this. So if you have an absolute value and we stretch it horizontally, it's going to like I'm taking your hands and pulling them out. See, it's going to get wider if we stretch it horizontally. Or if we shrink it horizontally, I'm pushing them closer to the y-axis. So if I shrink it horizontally, they're like this. So there's some examples. And then when we actually go to do stuff to the equation where the vertical we would multiply, we do the opposite of multiplication, we would divide. So if we have a 2x, we would be dividing by 2. But if you don't want to divide, you can multiply by its reciprocal. What's the reciprocal of 2? Okay. So I'm actually going to do the reciprocal thing, but you'll see. So that's summarization of everything. Let's do examples. Oh, and that talks about the negative being a reflection. Let's do examples. So the first thing you want to do is figure out what the parent function is, and let's plot the parent function and put it in our table. So look at 2x squared minus 4. What's the parent function? Huh? X squared. Quadratic, yeah. So we're going to plot that parent function. This is what you were supposed to do in your homework last night. Or from Friday, I should say. I don't know when you did it. Then when I have stretches and shrinks, I think using the table makes it a lot easier than trying to do it by hand. That's just my opinion. You can certainly try to do it using the graph and not use the table. It's up to you. So for this one, what transformations do we have? Do we have any horizontal ones? Are there any parentheses? No, it's just x squared. That's by itself. So there's no horizontal. It's only vertical. So we have a 2 being multiplied by the function. That means we have a vertical stretch. And you write vertical stretch
by a factor of 2. So you write vertical stretch by a factor of 2. Those of you that worked ahead, vertical stretch by a factor of 2. And then the -4 is a translate 4 units where? Down. So I'm going to do this using a table. You could do it by hand, but I think the vertical stretch makes it get a little confusing. So in the table, what am I going to do first? Multiply or subtract? Always order of operations, multiply. So in the table, we're going to take all of our y values and multiply by 2, because it is a vertical stretch. We take all our y values, multiply by 2. And then after that, subtract 4 from our y values. It goes down, so subtract 4. And then when you graph the outermost ordered pair from each 2, 4. And then this one is narrower than the other one. I just want to make sure that it still looks like a U shape at the bottom. Don't make it look like a V. Make sure it still looks like a U shape. Once you have that, if you want to try the domain and range, I'll go over that in just a moment. Or you can plot your parent function for the next one if you're ready to go on. Here's a good idea. I see some of you using 2 colors, one for the parent function and one for the new function. Which one should you do in the pen? Do the parent function in the pen, because if you make a mistake on the new one, you can erase it, but the parent one should be the same every single time. So that's a good idea. We got a lot of people that were doing it opposite. They were doing the parent function in pencil and then I would do white out. All right, the domain for this one is all real numbers, so we will write -infinity to +infinity. And then the range goes from down to up. So our lowest point is -4, and it does equal -4. It goes all the way up to +infinity. So domain and range. If you're ready to go on, plot the parent function on the next one, so I can just do it fast when I get there. Did you factor? All right, so I'm going to plot parent function. Parent function still squared, so we still have this quadratic. All right. So this time, do we have any horizontal transformation? Horizontal transformation? Yes, we do. We have parentheses. But also inside, with the parentheses, there is a number multiplied by the x and a translation. And that happened in our homework on Friday. And when that happens, you have to factor that number out from both terms. You're going to have to factor it before you do it. So we're going to have negative and then parenthesis 2 and then a new parenthesis. We're going to factor out that 2 and we're going to get x plus 3 because you're dividing it out. And then we'll have a double parenthesis closed squared minus 1. If you don't do the factoring step, your answer is going to be slightly different than mine. Then from here, let's write our transformations. There's quite a few of them. Let's see, I'm just going to look for anything multiplied first. We got a negative sign in front, so that's a reflect in the, which one is that if it's outside the parenthesis? Reflect in the x-axis, right? And then the 2 is inside. The 2 is being multiplied. It's on the inside, so it's horizontal. So it's opposite of what you think. So it's a horizontal shrink by factor of, I hear it, yeah. By factor of, and you have to reciprocate that 1/2. And the reason why I reciprocate it is because we're actually dividing by 2. But instead of dividing by a number, we multiply by the reciprocal. So you do the opposite of multiplying by 2. And then we also have 2 translations, but I'll just write them as one. Translate 3 units left and 1 unit down. When we go to fill out our table, you always do multiplication first. And then adding, subtracting. So reflect in the x-axis is a vertical, so we're going to multiply our y's by -1. And horizontal shrink is horizontal, that goes to the x's, multiplied by 1/2. So that'll be my first steps, is the multiplication steps. And then just to review, when we multiply with fractions, you take -3 and you multiply by 1/2. You have to make -3 into a fraction over 1. And then you go straight across. I graded your quizzes, that's why I'm reviewing how to multiply fractions. Some of you forgot. Okay, so we go straight across, we get -3/2. You could also think about it being divided by 2 instead of multiplied by 1/2. So -2 divided by 2 is -1. -1 divided by 2 is -1/2. And then from there, now we do our translations. So the y values go down 1, and the x values go left 3. So we're going to subtract 3 from the x's. So from -3/2, I have to subtract 3. I have to go more negative. So it might be easier to take -3/2 and write it as -1.5, and then subtract 3, go 3 more negative from that, because it would be -4.5. And -1 minus 3 is -4, and then next is -3.5, and then -3, -2.5, -2, -1.5. So the x's are always evenly spaced, so once you figure out the pattern, you can just fill in the rest of them. They're always evenly spaced when you do transformations. And we'll just, I forgot to do my y's. Take away 1. And then we'll graph those. -4.5, -10, -4, -5, -3.5, -2. And if I'm going too fast, these notes will be put on Canvas. The video will be posted on Canvas also. From here, the domain and range. Domain is all real numbers, so -∞, +∞. And then the range goes from down up. So the lowest is negative infinity, and the highest is negative 1, and it does equal negative 1. So you ready to go on? Plot your parent function on the next one. Should be a horizontal. And you don't want to fold it one half out. We're not folding it. Okay. So question C, do we have anything horizontal? Do we have any parentheses for question C? Do we have any parentheses? Do you guys see parentheses? No. But there are some there. They're understood. So what is the parent function for question C? What's the parent function for question C? Yeah, just square root of x is our parent function. So then to know if there's anything horizontal, is there anything being done underneath the parent function, underneath that square root? And the answer should be yes, there is. There's something multiplied and something subtracted. So if I have something multiplied and subtracted, guess what I have to do? I have to factor out the half. So we're going to have 1/2 parenthesis underneath the radical. 1/2 parenthesis x minus what? 4. How did we do that? We took 2 and we divided it by 1/2. Or we took 2 and we multiplied by the reciprocal of 1/2, 2/1, which is 4. Or if you think about it going back, if I took 1/2 and I multiplied it by what number, it has to equal 2. 1/2 of 4 is 2. So that's factored correctly. Then we can write our transformations. The 3 outside is a vertical stretch by factor of 3. The 1/2 on the inside is a horizontal, but it's always opposite what you think. So if it's a 1/2, it's a horizontal what? Stretch by factor of 2. Flip it, 2. And then translate 4 units right. So my parent function is 0, 0, 1, 1, 4, 2, 9, 3. And my translations, I'm going to start with anything multiplied. So I'm going to multiply my verticals by 3 and my horizontals by 2. And then after that, I have a horizontal translation plus 4. So we're going to graph our outermost ordered pair, so 4, 0, 6, 3, 12, 6. I'm off the graph by then, but there's a little room you can fit it. then we'll write our domain and range. Domain is left to right, so all the way to the left, the blade function starts at 4 and goes to positive infinity, and then down to up for range, so down to 0 and goes to positive infinity. So when I start going over this, it should be 8. I think so. I don't have it. All right, last one. Okay, so parent function, which is this one? Absolute value. Okay, do we have anything horizontal? Yeah, we do. We have a 4 inside of the absolute value. So we've got a horizontal, that one's going to be a shrink by factor of 4. And then that 1/2 on the outside is a vertical shrink by factor of 1/2. And then the -2 is translate down 2 units. So horizontal shrink by factor of 1/4. That means you're going to have to multiply your x's by 1/4. So I have a parent function there. Do I have to use those points? Because if I use those points, I'm going to get a bunch of fractions that are going to be hard to graph. What could be a different point that I could put here that might be a little bit easier to multiply by 1/4? 4 or, well, I got the 2's, but 4 or bigger number? 8, okay. I'm kind of deaf, I can't hear you. Or -4 or -8, either. So maybe I might choose to do that and maybe skip some of these other ones that are just not going to be fun to multiply with. So multiply 1/4 times 0. That is 0. Multiply 1/4 times 2, that's 1/2. Times 4 would be 1. Times 8 would be 2. And then on the y side, I'm multiplying by, is it 1/2? Yeah. So I have 1, 1/2, 0, 1/2, 1, 2, 4. And then after that, I'll be translating my y's down 2. So -2 to my y's. So I'm only going to do it to the ones that look easy to graph. And then graph -1/2, -1. 0, -2. confusing. Oh, this one's wrong, right? Okay, so then that's -1. 1 is 0, 2 is 2, and they mirror each other, so you can fill those in. Domain's all real numbers, so -infinity to +infinity. And range goes from -2 to +infinity. All right, ready to go on? Turn the page so I know we can go. And if you were working ahead, we are now doing that other section that you may or may not have known how to do. Okay, now what we're going to do is we're going to be writing equations, and I'm going to give you a method that's going to work, but you may just choose to just kind of try to figure stuff out also. You don't have to use the same method that I'm showing you. The reason why I'm showing you this crazy method today is because we're actually skipping a section in the book that teaches you about function notation, but a lot of you learned about function notation last year. And then we need to know function notation when we do section 1.8 in the book, which is coming up next. I'm going to show it to you within this lesson. So we're going to write a function g whose graph represents the indicated transformation of the graph of f. And we're going to follow the correct given order, simplify the functions where appropriate. So when I say follow the correct order, I'm not talking about order of operations. I'm talking about when this says vertical stretch by a factor of 2 followed by a translation 1 unit, you have to do this first part first. You have to do this first part first, then the second part, or you might get it wrong. So I'm going to start with talking about this first part, and I'm going to give this function a name. This function is going to be called h of x. It's kind of like the in-between function. And to get h of x, we take f of x, and we multiply it by 2. So in the first page of notes, there was like a multiplied by f of x when we were doing the notes. So this is going to be the in-between function. We're going to take the f of x, we're going to multiply by 2. What is my function, my f of x function? What is it? What is it? It's x. It's right there. So really what I'm doing is I'm doing h of x is 2 multiplied by x. Now you may have just been able to get that without this h part. I'm just trying to show you for when it gets harder what I'm doing for when it gets harder. Okay, and then from there we're going to take h of x, we're going to take the previous function, and we're going to do translation of 1 unit up, and that's what I'm going to call my g. So my g of x, my final answer, is going to take the previous function, h of x, and translate 1 unit up, so plus 1. And then you plug in what you know. Well, g of x is h of x, and h of x is 2x. That one did not require any sort of simplifying. It was pretty easy. You just step this up in. Okay? And I saw a lot of you already had it before we went over this. So the way you did it was fine. Question B. Translation 3 units down followed by a vertical shrink by a factor of 1/3. Order matters, so this first part is going to be our h, and the second part will be the g. So h of x, translation 3 units down from h of x, from f of x. So I'm going to take my first function and subtract 3. So I have my first function, which is x squared, minus 3. Is there anything to simplify? No. We move on. The second part says now we're going to do a vertical shrink by a factor of 1/3, a vertical shrink by a factor of 1/3. That means to take the factor, 1/3, and multiply that by the previous function. So I take 1/3 and multiply it by our h. So what is our h of x? X squared minus 3. You notice how I had to put parentheses in there because I'm taking 1/3 of the entire previous function. Now there is something I can simplify here. I can distribute the 1/3. So I have g of x equals 1/3 x squared minus 1. Okay, so I had to distribute on that one. All right, next is f of x equals absolute value of x. Horizontal shrink by a factor of 1/2, followed by a translation 4 units to the left. We're going to first do horizontal shrink by factor, of 1/2. Where did it go? Okay. That's going to be my h. So on that first page of notes, when we have a horizontal shrink, just go back to it real fast so you don't have to turn. When we had a horizontal shrink, do you see how it has f of, and then it has the number inside the parentheses with the x? So I'm going to show it in that symbolic form. So we're going to have f of, what number am I going to put in there? 2. Now when you have f of a number, that means you're going to replace x with 2x. So wherever I see an x in the original f function, in that function, wherever I see an x, I'm now make it 2x. So we have h of x, h of x is equal to absolute value 2x. So wherever I saw an x, I made it 2x. Do I need the parentheses? Okay, so h of x equals absolute value 2x. Then we're going to do the second part. So the g of x is going to go off of our h. So we're going to do h. But I have translation 4 units to the left. What goes in the parentheses? What? Plus 4, yes. So we're going to have h of x plus 4. And what that means is replace x with parenthesis x plus 4. In the h function, wherever I see an x, I make that into parenthesis x plus 4. So we go back to that function. And I have absolute value 2 parenthesis x plus 4. Close the absolute value. And does that simplify it all? Does it simplify? Yes. So we can distribute our 2. Absolute value 2x plus 8. That would be fun. So if you were figuring this out by hand without doing the h into the g, horizontal shrink by factor of 1/2 followed by translation 4 units to the left. Remember, when you have multiple things happening in here, you have to factor that number out. And we always do the multiplication before the translation. So you can kind of see there's the 4 units to the left and there's the factor. All right, D is f of x equals absolute value of x, translation 4 units to the left, followed by a horizontal shrink by a factor of a half. It's the same as the previous one, it's just in the other order. The first thing that we're going to do is the h. So h of x, and this is 4 units to the left, is the same as f of x plus 4. That's where we're going to start. And wherever you see an f of and the stuff's inside the parenthesis, that means replace x with parenthesis x plus 4. So to replace x with parenthesis x plus 4. So h of x is equal to absolute value parenthesis x plus 4. But I don't really need the parentheses there. And then to get the g function, we now have a horizontal shrink by a factor of 2. So we're going to do the h of x, but we're going to do h of 2x instead. So in the h function, wherever you see an x, make it parenthesis 2x. Absolute value, parenthesis 2x plus 4. And then do I need the parentheses there? Nah. So absolute value 2x plus 4. You can see that when you go in a different order, the answers will be different. So you make sure the order matters. Okay, last one. Last one. F of x equals 1 over x, vertical stretch by a factor of 5, and a reflection in the x-axis, followed by a translation 3 units right and 4 units down. So the first part has a vertical stretch of 5 and a reflection in the x-axis. So reflection in the x-axis, is that a horizontal or a vertical? Not sure, you get out your x-axis and reflect something over it. Which way am I going right now? Vertical. So that means it's going to be outside of the function. And a vertical stretch of factor of 5 is also vertical. So both of them, negative 5, are going to be outside of the function. We're going outside of the function. So we have negative 5 multiplied by my function is 1 over x. Can I multiply negative 5 by a fraction? How? I multiply. Put negative 5 over 1, and then what? Straight across. So h of x is negative, and I'm just going to leave the negative outside, 5 over x. I'll just leave the negative out front. The whole thing's negative. You can put it on top or you can leave it out front. It doesn't actually matter. Either is fine. Then our g of x says to take our h of x, and we're going to have a translation of 3 units right and 4 units down. So we'll have h of x minus 3 and then minus 4. So wherever you see x, replace that with x minus 3. Wherever you see x, you make it x minus 3. And then the minus 4 goes on the outside of the function. So that's what that function would look like. And I could put parentheses around the x minus 3, but they wouldn't do anything, so I didn't do it. Okay, I'm going to come around, pass out your worksheet. Let me just put this up real fast. The assignment is a worksheet, and then we have one more section that we're going to cover in Chapter 8 before preparing for a test. It's coming up soon, but we have this long weekend. The test will be block day next week. So we'll have this block day this week. Everybody knows there's block days this week. And then the test will be block day next week, so you'll have a longer period to do the to do the test.